if you are watching this one online, watch one of my other class videos to where I go over this problem. I go over this one at the beginning of the other two videos. Just watch this video, then you're fine. Actually, I guess probably watch the beginning of this one too. So if this end part says, which is the largest confidence interval for which the confidence interval will not contain 0, am I dealing with the left scenario or right scenario? Because this one does not contain. So I'm over here, and if I'm over here, I know that we're going to do what? Reject. And we reject when the p-value is less than alpha. So that was my thought process getting through this problem. If you can get to there, this problem, there's one last thing. If my confidence interval is 90%, what is my alpha? Because if it's between here, what's it between here? 90%, so it's not between here 10%. So for B, the alpha would be 0.07, then 0.05, 0.02, and 0.01. I think some people have an issue with just that part. Now it's a super easy problem. Our p-value was given. Is my p-value less than 0.10? Is my p-value less than 0.07? Is my p-value less than 0.05? So now, which is the biggest confidence interval that did reject? Because I rejected here, I didn't reject here. So this is the biggest one that still does reject. And I think that actually working through that correctly and getting to the right answer, I think that's one of the hardest problems on this multiple choice. Even though it's easy once you get there, there's a lot of tiny pieces in there. E.
How is the 0.07 one bigger than the 0.1? Is it the difference?
Okay, it asked for the biggest what?
Oh.
And then so again, that's another tiny piece that makes a big difference, and that's why I think this problem is so difficult. This one concerns me. Because this one, if somebody said pick one problem on this whole test that is probably like the best representation of the core of our class, I would probably pick this problem. And this is the 9th most missed problem for our classes. So that part concerns me a little bit. So let X represent a random variable whose distribution is normal. Anytime you see this word, you really need to circle it, star it, underline it, make a note of it. With a mean of 100, standard deviation of 10. Which of the following is equivalent to probability that X is greater than 115? What does normal mean to you? If I say normal, what's the first thing you would probably do?
Like bell shaped.
All right, now how do I use the fact that mean is 100?
It's going to be like the center.
How do I use the fact that the standard deviation is 10? And I can keep going 3 each way. I just know this problem I only need 2 of them. So if I were drawing this one, I would draw a line at 115. I'm shading above it. And I want to know which of these matches that one. I'm going to draw a curve like this for each one of them. Now, most of you aren't going to go through all this work for all of them, but for me going over it, I want to. I'm just going to draw the middle and 2 each way, and not write the numbers in, and just know that I'm dealing with the same ones. So here's my 100, 2 this way, 2 this way. A, B, Alright, so A, I'm starting at 115 and shading which way? Left. For B, I'm starting at 115 and shading which way? Are A and B different? No, because we're finding an area, the area of a location is 0, so these mean the same thing as far as we're concerned with. C, we're starting at 85 and shading left. D, we've got a line at 85, a line at 115, shading in between. And E, it starts with drawing a line at 85 and shading left, but then we're doing 1 minus that, which means we're actually shading to the right. Which one correctly matches the same area as the one over there? Now, you could go farther to the fact that you could convert all these to z-scores. My other classes, I'm going to draw it up there. My other classes probably wouldn't choose to do that and would at least think the way the picture is. Some of you in here might think more like the z-score thing. These are really easy numbers, which it usually gives you on the AP exam. So mean of 100, standard deviation of 10, that makes it super easy to work with. Here, that's 15 above. 15 divided by 10 is 1.5. So this gives you probability that Z is less than 1.5. This has been working. This one is probability that Z is less than or equal to 1.5. What kind of Z value do I get for this one? Because it's this way instead. Here is less than negative 1.5. Here I'm saying Z is between negative 1.5 and 1.5. Here I'm saying 1 minus the fact that it's less than, so it ends up being and this one is, so Z being greater than 1.5 is the same thing as saying what?
Z is less than negative 1.5.
And some of you are just going to go through it that way instead. It's the same thought process, it's just with a picture without a picture. But that's the kind of problem where I'd probably say that was the best description of the core of our class. So you need to make sure you at least feel okay with that. All right, the graphs of the sampling distributions 1 and 2 of the sample mean of the same random variable. This is really important that most of you are going to overlook. That just means like if I'm pulling out of this bucket, I'm pulling out of this bucket for both of them. For the sample of 2 different sizes are shown below, or shown above. All of these are asking about sample size and what it does. Finish that statement.
The variability increases, the width increases.
And everything that you're saying is fine. Variability spread, width decreases. This is our 10th problem, and this is the second time we've written the same exact thing. So, looking up here, does distribution 1 have a bigger or smaller spread?
Smaller.
So this one has the spread that's bigger. So if this one has a spread that is smaller, it has the what in?
Larger sample size.
Which means this one has a smaller sample size. So the sample size of 1 is less than the sample size of 2, yes or no?
No.
Sample size of 1 is greater than the sample size of 2.
Yes.
This one says they're the same. That's obviously not true. This one says sample size does not affect it. That's definitely not true. Sample sizes cannot be compared. Technically, the only reason we can compare is because it's from the same random variable, but most of you are going to overlook that part.
Would there be something like that where it would?
As far as your class, no, they're not going to make you compare two things that are completely different.
Okay.
That's what I'm saying. Like, yes, that's really important, but for our class, you're not even going to pay attention to it. All right, number 10. Distribution of the diameters of a particular variety of oranges is approximately normal. Definitely need to do something there. Highlight, circle, underline. With a standard deviation of 0.3. How does the diameter of an orange at the 67th percentile compare with the mean? What did we say we start with because we know this?
The shape. Then
Now, how do I do this?
you find the area which would be 0.6700, and then find the closest z-score to it.
All right, so I'm going to do a step in between just to make sure I'm covering a detail. Finish that statement.
To the left.
So percentile means always shade left. So if I drew my line at 0, what percentile is that?
The
50th. So I'm shading more than the 50th, so where's my line going to be? And then, so now I'm at the point that she was talking about. So here is 67% that is shaded. I'm now looking at my green sheet in the middle because it's an area. And then I'm finding the closest thing to 0.67 and following it out to the closest z-score, and I get what?
44.
Everybody with me there? Alright, so this is a what kind of score?
Z-score.
Alright, so what's our generic z-score equation? Alright, do I know this?
Yes.
What else do I know? And I don't know either one of those. Well, math here, what am I going to do at that point? Multiply 0.3 to both sides, and right now I have what does that mean in words?
Observe the
So it's how far I am
from the effective to the mean.
from the mean. It's not asking asking us what each value is. It's asking how I compare to mean, so where I am in relation to mean. As soon as I drew this picture, I should have looked at my answer choices and marked out what?
The below the mean.
I know that I'm above the mean, and so that could narrow me down there. So I just have to figure out how far above the mean I am. How far above the mean am I? Now, that ends up being confusing because people are like, why did I stop there? Which I get. So let's come back to this if you wanted to think about it a different way. So if I am drawing my graph, my z's would be 0, 1, 2. I can keep drawing more. My values, or I don't know what this is, but this is my mean. This is my mean plus what? Which is, and this is my mean plus this is here, which is just under halfway from here to here. So at 1, I'm 0.3 above the mean, so I'm about halfway. So this is the only one that's less than half of that. Like you're literally just thinking of 0.441. And so I think it makes more sense to think about it that way because it's conceptually, but the other way I did it is really the right way to do it. But worst case scenario, you should get down to C through E just because that picture, you know this is more than that, so it should mark out that one. So I would really expect you to get down to C and D even if you got confused at that point. All right, so this is our 12th problem, making sure you are keeping up. All right, histograms represent the distribution of 5 different data sets, each containing 27 integers, 1 through 7 inclusive. You do not need to understand this part to answer this question, but this type of problem comes up a lot on the AP exam, and sometimes understanding this part is like a little bonus, or you could think through it a different way. What do you think this part is talking about? So each bar of the histogram. So this is 1, 2, 3, 4, 5, 6, 7. What do you think this means in terms of the problem?
That's the sample size.
If you were to actually break this down like proportionally, so there's 1 here, 2, 3, 4, 5, 6, 7. If I added up those numbers, I'm going to get 28. Understanding that, like I said, a lot of problems are set up using that type of thing. Sometimes it doesn't even give you these, but you can still look at a problem like this and break it down in pieces like that and think about it, even if you make up your own numbers and put them all on the same scale. So that might help you later to be able to do something. All right, now, so this problem says, which one has the largest standard deviation? What's the definition of standard deviation?
The average distance from the mean.
All right, so, and I'm going through this one really slow on purpose. Some of you are going to pretty much jump straight to the answer, and that's good. Let's draw a line for where we think our mean's going to be. Well, these bottom 3 are really easy. Where's the mean of this one going to be? Same thing here. Same thing here. These, there's more weight here, so it's not going to be here. It's going to be shifted a little bit. This one, it's gonna be here, but shifted a little bit, but not as far as that one, so still like somewhere in here-ish. So we need to figure out how much pull from that line each bar has. So like if I'm thinking about this bar, how much pull does that bar have from the mean?
Almost none.
It's 0 from the mean. So everything that's in here adds a 0 to the distance from the mean, right? Whereas something out here would be 3 from the mean. Do I have a lot or a little pull that has a pull of 0? A lot. Do I have a lot or a little pull that's my highest number? Little. So I've got a lot of pull of 0, not a lot of pull of a big number. Which of these two has a higher standard deviation? E, because here I'm contributing a lot that's just 0. Here I'm at least dispersed where I have more out here, so that one's bigger. Here, I don't have much that contributes 0. I have a lot that contributes the farthest away. Here, the same idea, but I have just a little bit that's this far away, and a decent amount that's that far away, but it's not as far away because it got pulled that way. What's your correct answer here? The most of the pull is not at 0. Most of the pull is farther from 0, as far from 0 as possible. Back to where I started. This is not what you should do as soon as you approach a problem like this. But if you have gone through the AP exam, you've got extra time. You've only got about 2 or 3 problems where you're like, I am just stuck, but I've got extra time. This is 1. There's 1, 2, 3, 4, 5, 6, 7 ones. This is 2. There's 6 of them. This is 3. There's 4. 4 is 5. 5, there are 3 of them. 6, there are 2. 7, there's 1. I could go to a list and type in 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, and so forth, and write down what my standard deviation for each one is. Do you understand how you can use a graph like that to break it down? So I'm telling you all this because if you can understand this type of stuff, sometimes you can think your way out of a problem that you can't figure out. Do I think you should start there? No. Do I think it is the best use of time? No. But if you're stuck, you're only stuck on a couple, you have extra time, that's an option to get out of it. Or maybe you're like, I don't know, but I know between these two it's this one, but I don't know how like this top section relates to the bottom section, and I might want to plug in just numbers for this one and just numbers for this one to make sure I feel good about it. Like you can kind of think through it that way.
So the answer is D?
Yes, the answer is D. I realize you're on your phone. You realize the only reason I haven't said anything to you is because this is a double quiz grade and you have yet to write anything down, so that's going to be 2 zeros for you. So type away on your phone, that's fine. Yeah.
How much of this we're gonna do today?
Do what?
How many of these we're gonna do today?
Maybe another 1 or 2. My other classes, didn't get to the problem we just did.
Oh, sorry.
All right, city is interested in building, this is an extremely easy problem. And this is an extremely wordy problem. Like it tries to confuse you in a very tiny way. A city is interested in building a waste management facility in a certain area. 100 randomly selected residents, there's my N, were asked, do you support the city's decision to build a waste management facility in your area? Of the 100 residents interviewed, 54 said no, 4 said yes, 42 had no opinion. Large sample confidence intervals constructed to estimate. I'm overlooking things on purpose right now. these are asking, is it valid or invalid? So we understand we're dealing with what part of the 4-step process? The conditions and plan. So for just looking at A, confidence interval is valid because sample size of more than 30 was used. What is that one talking about? What's this called?
Large numbers.
Central limit theorem. Yes or no?
Yes.
No.
Why?
If you want it to be more, that's for more like.
That's for means and not proportions, and that is a constant issue that people across the board in all of my classes are having this year. So just because this is proportion, where do I see the word proportion?
Oh, yeah, right away it's wrong.
Alright, so that's my first thing that I need you to know. Now, let's back up and think about this a little bit. I've got p hats and 1 minus p hats. What is, in general, what is p hat talking about?
Predicts probability.
Probability of what? In general. Success, and this is what? Do you see an issue?
Yes.
Okay, so we have to think through this part first. What did it want to know the proportion of? So this is super, super, super important that people are going to overlook. What is my, which number is talking about my success?
4.
So it either is my success or it's not. So it's 4 versus 96. Does that make sense? So now that I can break it down to that, what is my normal condition for
It has n times p hours greater than 10.
and what is my number of successes going to be?
4.
4. What is my number of failures going to be? 96. Is that an issue?
Yes.
So easy question, confusing wording. Yes.
Can you go over E?
Oh yeah, I want to go through all pieces. So confidence invalid. It is valid because each resident was asked the same question. Now, should they be asked the same question? Yes. But just because I asked them the same question, does that make it valid? No. Confidence interval is valid because no conditions are required. No. And then E, the confidence interval is not valid because no opinion was included as a response category for the question. This goes back to what I was saying here that people are going to get confused with. When we think of successes, failures, like rolling a 6, there are 6 options when I roll a die, but we can categorize it as getting a 6 or not getting a 6. So we categorize this one as do support, do not support.
Isn't there also no opinion?
So did these support?
Yeah.
So we can break it down as yes, not yes, and just put them together. And that, I understand why people get confused with that. That's why the wording is the confusing part. Other questions with that one?
Can you find out it's not valid before like even doing it? You're kind of
What do you mean?
reading it and no, it's not valid. Or
Say that again. Like, what do you mean?
can you just read it and tell that it's not valid, or do you have to go?
You would actually have to do the conditions, like check the conditions. Yeah.
Or if it is stated like that one was like 4 yes, can we just say 4 is less than 10?
Yes. Yeah. If you understood that part, yes. That's what I'm talking through this one in a much longer process. But yes, some people are just going to flip to 4 is less than 10 and then go straight to that. This one is going to take a lot. This one is surprisingly a lot of work for one multiple choice question. I I do not want to rush myself on a multiple choice question. We are ahead. Let's stop there.